Hey guys, welcome back. Today we're going to be looking at ratio tables. That's step up number 4. Again, we're still using ratios, same thing that we've been doing for a while. Again, ratios are where you're comparing two different sets of data. So at the top it says a ratio table showing equal ratios can be used to solve a proportion. Don uses 11 skeins, never heard of it before, of yarn to make 4 scarves. So 11 of those things, whatever they are, to make 4 scarves. How many scarves can you make from 66 skeins? So if 4 come up to 11, we have to figure out how many would it take to come up to 66. So basically we're looking at these as 2 fractions almost. So we're looking at whatever we do to the bottom, we must do to the top. So 11 times what equals 66? 11 times 6, and 4 times 6 is 24. So in order to make 66, in order to, in order to get to the bottom, 11 times 1 equals 66 times 6, and then 4 times 6 is 24. And then you can see there is a little table as well. This is number of scarves. So for 4 scarves, you get 11 skeins, 8 for 22, 12 for 33, 16 for 44, 20 for 55. So this is all going up by 4 each time. And then this is all going up by 11. And then how are we going to get this number? Well, we already kind of figured that one out. That was just going to be 24. So again, we would need 24 or 66 skeins to make 24 scarves. And that's what we're doing today. We're kind of creating these tables. We're comparing these numbers, figuring out what is the missing number, and then finding the rest of the table. So if we look at this one, we know that 25 to 200. So how many 25s go into 200? Well, we know 25 going into 100 is 4 of them. So into 200 is 8 of them. So this is times 8. So now we have to think to ourselves, what times 8 equals 1,000? Okay, we could do that. We can go 8 into 1,000. 1, 25, 24. Oh, that's what I did wrong. Oopsie poopsie, I put 25. 20 there. 1 times 8. Then bring down, how many times is 8 going to 22? And now we have 60. Oops, it's early. And then last one, how many times is 8 going to 40? 125. So that means we know that this would be 125. We can also think to ourselves, well, this number times what equals this number? 200 times 5 equals this. 100 times 5 is 125. We can kind of keep on completing that. Again, if we're just doing this times 5, you go 100 times 5, 50 times 5, 25 times 5. So you can kind of compare those numbers as well. From the top to the bottom, what are you doing to this to get to that? 200 times 5, and then doing the same with the rest of them. For number 2, we have number of batteries and number of flashlights. So we know for 3 flashlights, we need 12 batteries. Now for 9 flashlights, how many would we need? Well, to get from 3 to 9, we times it by 3. Same over here, times it by 3. 12 times 3 is 36. And now we have to kind of put that in over here. So we have batteries into flashlights. 36, 9, 12, 3, and then we have to come up with a couple more. So you can just come up with, well, how many batteries do I need for 1 flashlight? So this is always divide by 4. So that'd be 4. And then what about for 2 flashlights? Times 4, 8. Again, for the blank ones, you can just put in whatever numbers you want as long as it follows the same ratio. It'll be good. So you could put 1 million in there. You could put 526 in there. As long as you look at the rule, which is kind of times 4 going up, you realize that it's okay. Next one, number 3. Blank yards equals how many hours? 800 hours. So for some reason, 9 yards, maybe they are knitting. 9 yards in about 8 hours. Okay. So now we have 800, or 8 times y equals 800, times 100, times 100, 900, 900, and 800. Again, we just have to have that same ratio. So maybe I'm just gonna put, it doesn't really, 16, because I'm just gonna times both by 2, 18. And now I'm just gonna times both by 3, 24, 27. As long as you multiply both of those numbers by the same number, you're good. So in this case, in order to make 27 yards of fabric, it took you 24 hours. Number 4, we have 4 carts and 24 horses. So let's say some horses are pushing some carts around. For 4 carts, we would need 24 horses. Okay. So right off the bat, we can kind of see what is the ratio. 4 times 6. So we need almost 6 horses for every cart. So now we have to figure out for 96. What times 6 equals 96? 16. Again, using that same ratio, we're just looking at the top number is times 6 to the bottom number, 1 times 6, and then 2 and 12. So again, you're looking at what is the pattern from the top to the bottom, and then adding in other numbers with it. For number 5 and 6, we have some word problems. Number 5 states, Katie was practicing her free throws. She shot 9 times and made 7 baskets. Wow. So she made 7 of 9. At this rate, how many times will she need to shoot to make 35 baskets? So the top is how many we made. How many times do we shoot? So again, 7 to 9. Now what times 7 equals 35? 5 times 5. So that means she would have to take 45 shots. Again, you're kind of just looking at these ratios as fractions that are equal. 6. Raul said that you can use the same ratio to solve the 2 proportions below. 8 cows to 2 pigs. And he said, well, is it the exact same as if we have 2 pigs and 8 cows? Do you agree or disagree that these are the same? So think to yourself, does it matter if the cows or pigs are on top or the pigs or cows are on top? So we have the first one, 8 cows equals, we have to work a little, and leave myself much room. Let's go this way. Equals 10 pigs. So we had to do times 5. 2 times 5 is 10. 8 times 5 is 40 cows. Now for this one, we have 10 pigs. 2 times 5, 8 times 5 is 40 cows. So in this case, looking at the top and the bottom, it doesn't necessarily matter where the pigs and the cows are. It doesn't matter if the cows are on the top or the pigs are on the bottom, because either way, according to the ratios, it's going to give you the same numbers. When you have two pigs and 8 cows and you times that by 5, now you have 10 pigs and 40 cows. If you have 8 cows and 2 pigs, again, doesn't really matter if the cows or pigs are on top, because you still times 5, 40 cows and 10 pigs. So in this case, Raul was right, because it doesn't really matter what goes on top or what goes on bottom. So that's what we got going on today. You can work on the next page, just the R page. Let me know if you have any questions.